Welcome to the next video on application layer. So in this video we would like to discuss about few of the application layer protocols, namely HTTP protocol, which is used for the creating of the web pages, and file transfer protocol. After this, we would also try to discuss an important protocol related with electronic mails, which is a simple mail transfer protocol, and finally we will discuss about domain name service. Let's have a quick understanding of what is this hypertext transfer protocol and how it helps us in designing of the web pages. So basically, what do we mean by a web page? What does it consist of? And how does this HTTP help us in creating this web pages? So any web page, it basically consists of number of objects. Now, what do you mean by an object in a web page? So the object can be an HTML file, a JPEG image, or a Java applet, or an audio file. You look at any website, try to click on it and try to observe the HTML content. You would find all these different types of objects involved. The web page basically consists of base HTML file, which includes several referenced objects. And each of this object will be referred by an URL. Example, this is an example of a URL like www.someschool.edu some department /gif. So this is the host name, and inside that host name we have a particular object which is referred to this path name. So let's have a quick understanding of hypertext transfer protocol and its overview. In this particular slide, you could find two particular devices which are trying to connect themselves to a server. So the server is the one which actually contains the web page. So this is the Apache web server which is containing the web page, and these are the two clients, the two PCs which are trying to access a particular web page on their PC. One is a PC and the other one is a mobile. Both of them are trying to access a particular web page which is being present in the server. So web's application layer protocol will be containing the content which is being tried to be accessed by those client devices. In the client server model here, a client is a one which tries to use its browser to which that it makes the request. At the same time, it receives the responses from the web server, and once it receives the response, they will be displaying that particular web page on their PC or mobile. So the client is the one which makes the request, and after receiving that response, it will be displaying that web page on its display. Similarly, the server is the one which actually receives the request from the client and will be in response to that request, it will be forwarding the objects in form of a response so that the contents will be displayed on the client system. Right. In our previous slide, we could found that a client is making an HTTP request to the server, and it is responding back with the HTTP response. Now, how is the connection established between the client and the server? For HTTP, the transport layer protocol which is used is TCP. So the client initially would make a TCP connection request to the server using a port number 80. So here the client is making a request to the server using a server's port number 80. Once the server receives the TCP connection request, it will accept the connection request. Once connection is a request is accepted, a connection is established between the HTTP client and HTTP server. In between the client and the server, you would find these two messages being exchanged. One is called HTTP request from the client to the server, and then an HTTP response from the server to the client, or exchange between this both browser of the client as well as the web server. So web server, we are referring it as HTTP server, and our PC or the mobile which is making the request, we are referring it as a HTTP client, and it is from the browser that it makes the request. So HTTP client will be referred with a browser. And once the data content has been transferred, then the TCP connection which has been established will be released. Remember, HTTP is a stateless. It means that the server will not maintain any information of the past client request. Right. So the type of HTTP connection between the client and the server is categorized into two types. The first type of HTTP connection is referred as non-persistent HTTP connection, and the second type of HTTP connection is referred as a persistent HTTP connection. Now what it is and how are they different from each other. For instance, I have three objects to be displayed on a web page. Now in case of non-persistent HTTP, every time a TCP connection will be established, one object request will be made, and after the object request is made, the response will be given to that and the TCP connection will be closed. So once again, for the second object, one TCP connection has to be established, then the HTTP request will be made and the HTTP response is transferred, and after the receiving the object, once again TCP connection is being closed. So in case if we have n objects, we have to establish n number of times the TCP connection, and in each connection only one object will be transferred. Whereas in case of persistent HTTP, here once a TCP connection has been established between the client and the server, then all the objects can be transferred, and once all the objects are transferred, then the connection will be released. So here we could save a certain good amount of time by adapting for HTTP persistent type of connection. Right. As mentioned in our previous slide, a non-persistent HTTP is a type of connection in which for every object a connection is established, and after the object has been transferred, the connection will be released. Again, the connection has to be established for the next object. Let us take a simple example to understand this particular non-persistent type of HTTP connection. So the URL which we are entering is www.someschool.edu/some-department/home.index. It contains text, references to the JPEG images. Now, HTTP client initiates a TCP connection to the HTTP server, which is www.someschool.edu on port number 8. Now, this particular request, which is made by the HTTP client, will be received by the HTTP server at the host, and once it is been waiting for receiving a connection establishment, and once it receives this request, it will be establishing the accepts the connection, notifying the client, yes, I have accepted your connection. Once the connection has been established, the HTTP client sends a HTTP request message containing that URL with the TCP connection socket. This message indicates that client wants a particular object. What is the object that it is looking at? It is looking at some department/home.index. So this is a second object which has been trying to be connected for the particular client. And after this, the HTTP server receives this request, and it will be responding in form of a response message containing the object which is mentioned and sends it through its socket. Right. So once this particular object which is mentioned by the client is transferred by the HTTP server, it will be trying to close the TCP connection. And this client which has made the request will be able to receive the response message which contains the HTML file, and now after receiving that particular file, it will be displaying that particular object. Okay, so this is how a connection has been made for one particular object. For instance, if I have 4 to 5 objects, for every object first a TCP connection has to be established. Once the TCP connection is made by the client to the server, server accepts, then the client sends the requested object, the server will respond back with sending the required object, and once the client receives the required object, it will display it and the connection will be closed. For next objects, all the 5 steps which we have seen have to be displayed. Right. So now let us look at what will be the response time in case of non-persistent connection. Now let me recollect you in non-persistent connection. first a connection request is made from the client to the server, and after server accepts it, then it makes a request for a particular object, and then the server responds with the required object. So if there is a estimation that the time taken for any data to travel from the client to the server and get back the response from the server is a time equal to round trip time, which is referred as RTT. So here, what is the HTTP response time in case of non-persistent? First, one round trip time is required for the initiate TCP connection. So here you are making a TCP connection request. The request is reached to the server and then it accepts the response. The total time required is RTT. And once the connection has been established, then the client will make a request to the server for a particular object. And once that particular request is received by the server, then it will respond along with the object. So the time taken here is one more round trip time plus the file transmission time. So if you take for one single object, what is the total time required? That is the response time of a non-persistent HTTP connection is RTT plus one more RTT plus the file transmission time. So the response time in case of non-persistent HTTP is 2 RTT plus file transmission time. Now let us try to understand how do we overcome the problem in the non-persistent connections. In non-persistent connections, we could observe for one single object, it requires 2 times the round trip times. One for the connection establishment and one for the object transmission. So there is an overhead for each TCP connection. And second thing is, every time we have to open a number of parallel TCP connections to fetch the reference objects. For instance, I have 5 objects, I have to make the 5 TCP connection establishments. Then only I could be able to receive all the 5 objects. Now, how do we overcome this particular problem is by switching from non-persistent to persistent HTTP TCP connections. What here it happens is, first the HTTP client makes a request to the HTTP server, then the TCP connection will be accepted by it, and after the connection is established and the HTTP client makes a request to the HTTP server. Now HTTP server in the initial case, after sending the object, it was terminating the connection, but here the HTTP server will not leave the connection. It remains the connection open after sending the response message. What has happened because of this connection still being active is, once the HTTP client wants subsequent objects, it can send between the client and the server over the same open connection. So here there is no separate TCP connection establishment again for the next objects. So since the connection is open, all the object requests by the HTTP client can be sent, and HTTP server on receiving those requests will respond back with the HTTP responses. So client sends as request as soon as it encounters with a particular reference object and as little as one. So here you could find a lot of time saving in case of persistent connections. Right. Now let us look at the format of the two types of HTTP messages. As already mentioned in the beginning, the HTTP messages are categorized into two categories: HTTP request and HTTP response messages. So first, let's have a look at the HTTP request message and its format. Okay. Generally, the HTTP request will be written in the ASCII format so that a layman or a simple person with a minimum computer knowledge can also understand the terms. Okay. The HTTP request message actually consists of two parts. The first one is called as request line. The second part is called as header lines. At the end, you will have something called carriage return and line feed, which is trying to indicate this is the end of the header lines. You could find in every line of this request and header, we are using this carriage return character and line feed character to indicate the end of a particular lines. Okay, so here let's have a first quick look at this different columns. The first line in our HTTP request is called as request line, and here we can have different types of requests like get or post, delete. Then sometimes you have head, and these are the different types. When do we use a get? Generally, when you are trying to open a particular web page, you are making a request for a particular web page, we are going to use a command called get. But if you are trying to search for some particular keyword kind of thing in a particular web page, then you are going to use something called post. The head is similar to the get command, and sometimes if you want to delete a particular contents, here the request line, instead of get, post or head, we can use it as delete. The second one is actually the URL from which we are trying to get the content or object. So first line is all about what is the type of the request which you are making. The second line is the URL from which we are trying to extract the content, and the third field here is the version of your HTTP. So here you talk about version of HTTP. So the current version which we are using is HTTP 1.1. So these first three fields are part of your request line. After request line, we will move ahead to the header lines, and here the header lines consist of different fields. The first one is the URL from which you are trying to extract the data, which is called as host, and the user agent is the browser from which you are using on your system to display the contents. For instance, I am using a Firefox 3.6 version, so that will be mentioned. And here you will have the accept the text, then different types of encoding schemes which you've been used, and the connections established, and finally the carriage written and line feed characters. In simple, if you want to summarize the header format of a request message, this is how it is. So here the first, it will be having this is called the header line, sorry, request line, in which you will have the method, whether it is get or post, or you can talk about delete. All those kind of things will be available in the method. In which URL you are trying to extract the data will be mentioned in this URL field, and the version of our browser will be mentioned here. Then you have the header lines, which is consisting of various header fields, names, as well as the values, and you will find everywhere we are using this carriage return and line field. Once all this, the entire header lines is complete, we'll once again use this carriage return and line field to indicate that this particular HTTP request header is done, and now it will consist of the entity body, which is a message which is actually been contained. In our previous slide, we have showed this, that this is a method of what we are using for the HTTP request, then the URL which we have been referring, and the version of our browser which we are talking about. Right. In the previous slide, we were talking about HTTP request message from the client to the server. Now in this slide, let's try to understand the response message which is sent by the HTTP client to the HTTP server. Now what do we have in this HTTP response? Here totally we have three fields. The first one is called the status line. The next one is called the header lines, and third one is the actual data, which consists of the objects. Now coming to the status line, this is trying to indicate what are the particular object which we are referring it. For instance, we have three columns. First one of the HTTP status line is the protocol version, then the code of particular response message, and the meaning of that particular code. This is what do we have in the status line. For instance, here in this particular status line, we have different status codes in the corresponding phrases. Here I have been taking a status code of 200, which means that everything is okay. And in the same to that of request message, here also every line will end with carriage written at line feed. After the status line, we have the header lines. In this particular case, you could find what are the various components of this header line. The date on which this particular object has been transmitted, then the server which has responded, just like in our user agent in our request message, to indicate the version of our browser of the sender user. Here the server indicates its particular Apache web server and its distance. Then when this particular content of this object requested was modified, will be mentioned by the last modified, and then you have this accept ranges and the content length, what is the total length of the object which you have been requested to transmit. Then we will be also having things like the remaining important elements, and finally the data which is being requested by that particular object. Right. In our previous slide, we were looking about the HTTP response message. Let's have the first line, which is called as the status line. We could find the three important columns. One is HTTP version, then the status phrase, and the phrase code meaning. Now here, what are the different status codes possible and what is the responding, the meaning or the message of it? As we have already seen in the previous slide, if our status code is 200, that is phrase code is 200, the message it means is everything is okay, the request which is made by the client is accepted, it is succeeded, and the object was being later transmitted. But in case if the status code is 301, it means that the object which you are mentioning has been permanently moved from that particular location. And in case if the status code is 400, then the particular request we have made is a bad request and the message not understood by the server. If the status code which is received is 404 in the response message, it means that that particular object has been not found in the server. And if the status code is 505, it means that the HTTP version of our user is being not supported. So these are the various response status codes which are possible in the status line of our HTTP response message. Right. Now let us introduce you one of the very important topics which really makes a lot of difference in the access time is web cache using proxy servers. So what do you mean by this proxy server and how do this particular help in reducing the time of accessing the content? So far we have discussed about a HTTP client and a HTTP server which provides those requested objects. Now in between the client and the server we are trying to introduce a proxy server. Okay, what is a proxy server and what does it do? So what happens is here user sets its browser and web access via cache memory. So here what it means is all the requests which will be made by the client will be first forwarded to this proxy server, and whenever any transaction is done, the proxy server will store those contents in the cache memory. For instance, next time I try to access it, for instance the same client is trying to visit the same website again, then proxy server will be storing the required port numbers and the contents in its cache memory, and it will directly return the object. For instance, a request is made by the client for the first time and the proxy server does not have the content, then the request will be forwarded from the proxy server to the origin server. It receives the responses here, and after receiving the response from the original server, the proxy server will return to the client. So what we want to mean is, in a proxy server, what it does is whenever a client tries to make access of certain web pages, it stores the contents in its cache memory, and whenever the request is repeated, it will directly send those content instead of once again sending the request to the server, origin server. If it is not having that particular content, it will be acting as a client and try to receive the content from the origin server and responds back to the client. Right. So what exactly the web cache and its service provided to the clients? Let's have a quick understanding. Now the proxy server which is implementing this web caching is acting both as a client as well as a server, as we mentioned earlier. For a client, it acts as a server and tries to give the content from its cache memory. So it's a server for the original requesting client, and for the actual server, it acts as a client. So your proxy server will be doing both the roles, and generally the typical cache by this proxy server is installed by the internet service providers. The major purpose of implementing web caching is to reduce the response time for the client server request, reduce the traffic on an institution's access link, and also with the caches, this will be helping us to better delivery of the content. So far we have been trying to understand about a HTTP protocol, and what are the two different types of messages used in HTTP protocol called HTTP request and HTTP response. And also we try to understand what is a proxy server and what is its contribution in reducing the access time for the web content. Now let's look at the second application layer protocol called file transfer protocol. So before we discuss about file transfer protocol, let me tell you, this is one of the frequently asked questions for the 5 marks in your university exam. So make sure you people understand the concept and able to present it in your exams. So let's have a quick understanding of file transfer protocol. So here, a user whom we are referring it as a host would try to either download a file from a server or to upload a file which is on its system onto a server. For that particular category of applications, we are using a protocol called file transfer protocol. So a file transfer protocol user interface will try to connect a user to the file transfer protocol client, which is our local system. And the file transfer protocol server will be referred as a remote file system, to which either we try to upload the file or to download a file from that particular server. So this particular application file transfer protocol is used for transferring the files to and from the remote host. And here once again we are referring the user as a client and our FTP server as server. So this is also a client server model, and FTP client or a user is the one that initiates the transfer either to the server or from the server. And server is our remote host. And the file transfer protocol, the technical RFC value is 959, ready for common value, and the port number which is assigned for the file transfer protocol server is port number 21. Let me tell you, there will be two different port numbers for the file transfer. One is for the data connection, which is used a port number 20, and for the control connections it is going to use a port number 20. As mentioned in the previous slide, the file transfer protocol is used to transfer a file onto a remote host or to receive a file from the remote host. So it is using two different types of port connections. The first one is the file transfer protocol client would like to connect to the file transfer protocol server using a port number 21, and this is implemented using a control connection. And the type of transport layer protocol we are using is once again TCP. Just like HTTP, here also we are using the service of TCP transport layer protocol. Client authorized over the control connection. The client browses the remote directory, sends commands over control connection. For instance, it would like to receive certain files from the particular FTP server, then it will be trying to send the commands over this control connection. And this is done through a TCP application transport layer protocol. And once the FTP server receives that particular file transfer command saying that I need a particular file, the server opens the second TCP. This time it's a data connection. The request which was made is over control connection, and now it is a data connection, and it will be trying to send the file to the particular client. And after one file has been transferred by the client server to the client, that data connection will be closed. So this is how a connection request by the client to the server over a control connection using a port number 21, and server responds with a data connection with a port number 20. So server opens another TCP data connection to transfer another data file. Control connection is out of band, and FTP server maintains the states of that particular thing, which is not happening in HTTP. So what are the various types of FTP commands and the responses we are being using in case of our FTP client server model? So let's look at some of the sample commands which we have been using in file transfer protocol. Here all the commands will be sent as a simple ASCII text. As simple as this, we want to know that even a layman need to understand it. And for instance, you are trying to access certain content for which you need to log in. So you are trying to send your type your username and password, and then return the list of files in the current directory. So here the list will try to indicate what are the different set of files which are presently available in a directory, and return. So to retrieve the certain files, we are using a command called retrieve. So one more command is store, which is trying to store the files onto a remote host. So if you are trying to upload certain files on a FTP server, we are using the store command. If you are retrieving certain files from the server, we are using a command called retrieve. And to know what are the files available on the server, you can use the list command. And what are the different sample written commands for the codes which you could find in this FTP case? Status code and phrase in your HTTP. So 331 indicates the username which you have entered is okay, and now you want a password. For instance, you are trying to access a particular page. First you will be asked to enter your username. If it is matching with the records, then you will be asked to enter the password. Similarly, we have a code called 125 which is being using for data connection is already open, and something like one other written code is 425 indicating that the data connection cannot be opened, or 452 indicating certain error in the code which you have been entered.